Welcome to a lesson with Dr. Powell. We're going to talk about the dihedral group of order 8. 8 things in this group. These are symmetries on a square. And I'll label the vertices 1, 2, 3, and 4. Now we're going to think about symmetry on these vertices as being something or something so that these dots get put back onto themselves, such as rotations. If I rotate, so think about this square and rotating it. If I rotate 1 to this position, then 4 would move over here, 3 would move there, and 2 would be moved there. So they would just interchange positions. There's only 4 counterclockwise rotations that would actually make this happen. The first one being the 1 would move down, then 4 would move over there, then 3, and then 2. That's one rotation, counterclockwise rotation. So I have do it once, do it twice, do it 3 times, or do it 4 times. It's actually doing nothing at all. So I'll label that as a 1 for the identity of this group. Now, I'm also going to throw in there a reflection, S. So what is S going to do? What S does is it looks at wherever I'm at, and it just reflects as in a mirror. So 1 would move over. So basically these columns interchange position. 2, 3, and 1, 4 would be the result of a reflection S. Now there is some neat arithmetic that happens. Let's suppose between S and R. Let's suppose that I have a counterclockwise rotation of a knob or something that I'm turning, and it goes 3/4 of the way right here. It's kind of clockwise. Now, from the other side, I've actually moved. If I reflect, what's going to happen is actually going to be so in the reflected picture, what this is going to look like from the other side will look like something like this, which will be clockwise. If I want to think about counterclockwise, then I would only go, then counterclockwise to get to that position would be move 1 rotation counterclockwise after I reflect. So what I could do is I could rotate 3 times counterclockwise and then reflect, and then my picture would look like this. Or I could be in this reflected picture, S, and then reflect and then rotate counterclockwise 1 time. These 2 things are the exact same. Meaning what I do first is on my right because this is composition. So I first do this, then I do that. So first reflect, you could even think of as being as go to the other side and look. Go to the other side and look, rotate counterclockwise once. Or rotate counterclockwise 3 times, then go to the other side and look. And the result will be the exact same. SR cubed is equal to RS. Notice that R and R cubed, which over here, are inverses of each other. And with respect to this operation of composition, R composed with R cubed is R to the 4th, which is 4 rotations, which is the identity. We're working mod 4 in the exponents. So this same type of thing holds all the time. So think about S R squared should be equal to R squared S, because R squared times R squared is 1. So 2 and 2 in particular are additive inverses mod 4. Now we could extend this even to other dihedral groups and get a similar type of arithmetic. What if we're working in D10? Symmetries of a pentagon. So what if I were to do SR cubed? Well, to switch the side S and R are on, so to do an S first, I would have an R squared. And that's because 3 plus 2 is 5. Thanks for watching.